apart from determining the position of the species in the electrochemical series, there is another factor will affect the product form, that is the concentration of a species. And if you go to the factor 2, is the discussion about the concentration on the effect of the product form. And let's say in this case for sodium chloride, because it's now in a concentrated environment, that is 3M as this molarity. And then if you compare, if in the electrochemical series originally for hydroxide ion is a stronger Ra than chloride ion. However, in this case, if you study the concentration of OH minus, it's just 1 × 10⁻⁻⁷ m, which is very low. And it actually favors the reaction of the reactant side into the product side. That is from the O2 side, absorbing electron and then back to the OH minus side. However, for the chloride ion, it's just the opposite because it's now 3M. If you compare this situation with the situation in 1M, then the backward reaction of this Cl2 plus 2 electron to become Cl minus will be less favorable. So what is the conclusion is that chloride ion under concentrated environment will discharge instead of OH minus. 就係話咧，你 electrochemical series 入邊咧，我哋比較緊啲咩就話1 M 嘅情況之下，同樣 concentration 之下，邊一嚿嘢咧係勁啲嘅 OA 或者 RA 啦，今次佢就係 RA 啦。咁啊，但係而家呢個情況就係話咧 ，Cl minus 咧佢好濃噶嘛，係咪？佢個 concentration 好高嘅，就反而令到佢嗰個 discharge 咧 from 呢個 chloride ion back to chlorine gas 咧就 more favorable 啦，掟個 OH minus。所以今次咧佢就會反而就會出咗嚟先啦嚇。And now we use a term called preferentially discharged to describe this fact. And what you have to tell other people is that under the same concentration, OH minus is a stronger reducing agent. Is the case in the electrochemical series. However, now the concentration matters. And the high concentration, much higher concentration of chloride ion will make chloride ion discharge to become more favorable. And this all we discussed last lesson. Oh, and then this time let's do a comparison if there is some dilute NaCl undergoing electrolysis by using the same setup. And maybe we draw it again and then to see what will happen. And again, just 2 inverted test tube. And then inside there are graphite electrodes. And then with some NaCl inside. However, this time we are using very dilute NaCl. And let's say maybe its concentration equal to 1 × 10⁻⁷ m. 咁啊，今次我用一個超級稀嘅 NaCl 做嘢啦嚇。咁啊，睇下佢同上邊嗰個 set up 嗰個分別係喺邊度咯？個 observation 上面嘅分別係喺邊度啦？如果你真係做嘅時候，你點樣知道究竟係呢嘢喺度做緊嘢啦？Let's continue. How will you start the analysis? What flow you should identify first?
Electron flow.
Or the electron flow. It will coming out from the negative electrode and then to the electrode on the on the right hand side. Oh, and then which species in the solution will be attracted to this side?
H plus.
H plus, and what else?
Na plus.
Na plus. And as I mentioned before, the concentration, it will not affect the discharge of the cation, and then with the fact that the H plus is at a lower position in the electrochemical series, so that H plus is a stronger OA in this case. It means that it will preferentially be reduced back to hydrogen gas. And this is the analysis on the electron on the right-hand side. And as you may know, this side should be the cathode. But then how about on the left-hand side? Which one should be the Ra?
Hydroxide ion.
Okay, the hydroxide ion. And if you really go into the consideration, there will be two Ra, possible Ra, ZR,
And chloride ion.
okay, and chloride ion. Thank you. So that there will be two equations. The discharge of the hydroxide ion and then back to oxygen gas. And then the other one is that the chloride ion, it can loses 2 electrons and then becomes Cl2. And the question is which of the hydroxide ion and chloride ion will discharge first? And as mentioned by your classmates this time, OH minus should be a stronger Ra because now they are under the same concentration, so that you can directly use the electrochemical series to predict which of them will preferentially discharge. So here is your whole analysis, is it? 佢哋而家咧兩個一樣喺 Fermi 大佬啦，我當佢最簡單嘅諗法就係都係1乘10嘅負七次啦。邊一嚿嘢會 discharge 先，咪就係睇翻 electrochemical series 咪其實搞掂咯，係嘛？咁啊 OH minus 就應該勁啲啦，所以佢做嘢啦嚇。So in this case, what can you observe on the cathode and anode respectively? Cathode first. What can you see on the cathode?
Cathode.
Gas bubble.
Gas
Right.
bubble.
Or gas bubble evolve, and that gas should be hydrogen. So
Hmm.
colorless gas bubble evolves. Oh, how about at the anode?
Also gas bubbles.
Or also gas bubble evolve, and what that gas should be?
Oxygen.
Oxygen gas. So that this time again, colorless gas bubble evolves. And this is the first evidence that how you can tell people that it should be under a concentrated or diluted condition. For concentrated environment, chlorine gas is evolved. So that what you can observe is a greenish yellow gas or yellowish green gas， 即係黃黃地、綠綠地色嘅 gas 會出嚟啦，係嘛？今次嘅兩邊出嚟嘅 gas 咧都係 colorless 嘅。And this is the first difference in the observation. Oh, and secondly, yes,
都會見到黃綠色嘅 gas 啊？
聽唔到。
係咪等耐啲都會見到綠色嘅 gas？
等耐啲，你要等佢啲水冇到一個地步，要 chloride ion 開始 discharge 咧，佢就會係啦。
Okay, thank you.
Oh, and then the other difference is the volume of gas in the two test tubes. Oh, what happened this time? Ah, 上次就大約1:1啦，係嘛？今次咧？ How can you think of the volume ratio?
都係1:1。
係咪1:1啊？我哋點知道㗎？上次我知道1:1係寫咗咩出嚟先嘅？譬如話 circle some evidence
啫嘛，今次
overall 嗰個
Okay, we have to write down the overall equation first. So what is the overall equation this time?
should be 2:1。
Why?
等我計一計先。
O 係1，之後 H 係2咯。如果比嘅話
O2 係1 ，H2 係2。And here at the bottom right corner, I show you the overall equation already. For hydrogen, its coefficient should be 2, and then for oxygen, it's 1 only. And because for all the gases, they occupy the same volume predicted by the ideal gas law, so their volume ratio is 2 to 1. So it's the second difference between these two setups.得唔得？第二個嘅唔同啦，除咗你見到佢哋喺嗰個 anode 嗰隻顏色咧，嗰隻 gas 色會唔同之外啦，呢個第一個 evidence 啦。第二個就係話咧，佢哋出嚟個 volume ratio 都會唔同嘅。咁啊，上次就大約1:1啦，係嘛？因為佢 reacting 個 ratio 嘅問題係 1 to 1啦。咁今次咧就調翻轉啦，好似調轉咗條equation寫喎，應該咁喎。Well, up to this point, any question you want to ask? Or if no, then just modification on the setup for using the concentrated NaCl solution. However, this time we add some more thing in it. It's an acid-alkali indicator, and we will see the effect of it. Oh, let's see now for the use of phenolphthalein. What is its color under acidic and alkali environment respectively? Hi.
Colorless in acid.
Colorless in acidic environment and
嗰個係叫 pink 定係 purple？
pink or red under alkali environment. So after the addition of it, some more observation you can predict. Oh, and let's go back to the analysis. 呢幅啦嚇。What can you observe at the right-hand side, on the right-hand side? On the right-hand side is connected to the negative electrode, so that H plus it will discharge. And what will happen if only H plus is discharged but not hydroxide ion?
變酸咗咯。
係咪變酸咗？
啲 hydroxide
喎，唔係鹼。
咁即係點啊？
咁即係成兜嘢會變 alkali。
係喎。
我又唔係成兜嘢啦，係淨係右手邊嗰支
我知
test
啊
tube 入邊咧，佢變咗做 more alkali 啫。
哦，I see, interesting.
So that on the right hand side, it should be the cathode because hydrogen ion is discharged. And then it will absorb 2 electrons to become hydrogen gas. And now there is only 2 choices for the oxidizing agent that are the hydroxide ion, I mean the H plus and also Na plus. And now H plus discharged preferentially. Okay. And then what's left is the excess amount of hydroxide ion. And given the fact that for hydroxide ion, it has a higher concentration than H plus, then the whole solution, it will become alkali. And obviously, because now originally the solution is NaCl, AQ, and this should be a neutral solution, so that originally is colorless. And therefore, the color of the indicator will turn from colorless to pink. H plus 同埋 hydroxide ion 一模一樣 concentration 啦，咁啊一樣 concentration 即係 pH 係7啦，喺正常 room temperature and pressure 之下，咁啊7咪透明咯，係嘛 ？phenolphthalein 呢隻 indicator， 咁啊但係之後啦，係嘛 ？H plus 慢慢少咗啦，咁即係 hydroxide ion concentration will become higher, and they will make the whole solution alkali, so the indicator will turn from colorless to pink. So then after the addition of the acid-base indicator, you have some more observation. 之前有同學問就係話嗰個 pH value 低咗高咗啦，算唔算係一個 observation？唔係啦，直到你幾時先至係啊？你加咗啲 indicator 落去，你就會見到嘢啦，佢就會係個 observation 嚟啦。Oh, how about at the anode？Anode
係出 CO2 gas 啊。
CO2 gas，and then
跟住啲 CO2 gas 就同 H2O react，is it？
Yes, to form
hydrochloric acid.
Hydrochloric acid and what's more?
Hypochloric acid.
Or hypochloric acid is HOCl, AQ. So as you may see on this side, because of the presence of that two acid newly formed, then the whole solution on the left-hand side, it will turn acidic. Oh, how about the color of indicator this time?
Colorless。
It remains colorless. 原本 neutral 係 colorless 啦，係嘛 ？colorless 去 acidic environment 都係 colorless 啦。So remain colorless at the anode. Oh, and another task for you. What if we use another two acid alkali indicator? First one, methyl orange is used. And secondly, what if universal indicator is used? Universal. If我轉咗隻 indicator 啦，又有咩會見到？俾幾秒你諗下先啊。
anode 轉 pink 係咪 red 啊？跟住 cathode 都係黃色。
係 ，thank you。哦，咁啊，你諗下最原本嗰個狀態咧，究竟 methyl orange 係咩色啦？咁啊，最原本咧 NaCl 咧就 neutral 嘅，係嘛？And then for methyl orange under neutral environment, it should be yellow in color because its reference range is 3 to 5. So that originally it is yellow in color. Oh, and then what happened in the cathode? Will it become acidic or alkali?
It becomes acidic 啊。
哦
有啲
要
cathode anode。
Cathode.
cathode will become alkali 啊。
Or it will become alkali. So this color, it will remain yellow. 有冇理解唔到啊？原本佢 neutral 黃色，變得更加 alkali 都係黃色，所以 it will remain yellow in color. And the explanation is just the same because H plus is discharged preferentially and then causes excess hydroxide ion so that the solution it will become alkali. Just because now another indicator is used so that the color change you have to think from the beginning. Oh, and then how about at the anode?
From yellow to orange.
Is it just from yellow to orange?
To red 啦。
有 HCl 應該有 red 喎。
To HCl, its pH value should be quite low so that it will be pink or red in color. 咁 orange 嘅狀態咧 ，orange 咧其實即係佢喺4咗緊嘅位置，佢就會啱啱紅色、黃色之間嗰個位嚟啦，係嘛？咁啊，所以佢都係會向嗰邊發展嘅。不過因為 HCl 佢 pH value 再跌低啲咧，佢就會變做紅色啦。Oh, and then one more observation here is that because for the HOCl, it has a bleaching property. Bleaching 嘅意思咧， 就係解漂白咁解啦。係。So after the indicator it turn in from red, yellow to red, then what will happen next?
再變 colour 咧。
colorless again 就係
Finally, the solution will become colorless because of the bleaching property of HOCl. Oh, finally, how about universal indicator if it is used? And I show you the color of it under neutral environment already.
screen
So it's green in color. Oh, careful 嗰邊轉咩色？
藍色啊 blue
我轉
藍色
藍色啦，你理解到啊？同上面嗰啲其實佢變 acidic alkaline 其實完全冇分別㗎，一模一樣嘅。問題呢隻嘢佢 alkaline environment 係咩色啫嘛，係嘛？And universal indicator have a color scale of a rainbow. So if it turn into an alkaline, it will be blue or it will be purple at the end. But we seldom see purple color for universal indicator. So usually we write it blue. Oh, and then NO.
From green to red.
From green to red. And similarly, because of the bleaching property of
Then
H2
colorless.
it will
or
become
HOCl, it will become colorless finally. And this is a whole set of results. So after studying the situation with concentrated and diluted chloride ion, we would like to study the electrolysis of another halide ion, that is iodide. Oh, and let's go back to the electrochemical series somehow. Oh, and the arrangement of the RA is like this: hydroxide ion, and then I minus, and then Br minus, and then Cl minus. And then as mentioned before, for Cl minus, only if this concentration is very high, then it will start to discharge. Then how about I minus? Is it easier for it to discharge or more difficult by comparing with Cl minus?
easier
easier.
Or easier? Why?
Higher position.
higher position in the easier series
Or is higher position in the electrochemical series than Cl. When the concentration of I minus is slightly higher than hydroxide ion, then it can discharge already. 明唔明講咩啊？Cl minus 咧，佢需要個 concentration 高到一個地步啦，好高 very concentrated 咧，先至可以令到佢贏過呢一個嘅 OH minus 啦，係嘛？但係咧 I minus 就唔同啦，佢同 OH minus 咧靠得太近啦，所以佢只要個 concentration 高過 hydroxide ion 咧，少少都好咧，佢已經會 discharge 啦。So for the case if you have a dilute I minus solution, it will discharge already instead of using a concentrated solution. So let's draw the diagram. Graphite electrode. And this time I don't want to collect the gas, so just use the simplest setup. So what happened on the left-hand side? This is the cathode, it should be the cathode. What happened on this side?
Reduction.
Reduction, which species will undergo reduction?
hydrogen I mean hydrogen ion
Hydrogen ion. It will absorb the 2 electrons and then form band H2. And if you want to write down the explanation for it, you have to make use of the electrochemical series, which of them is higher or lower, then which of them is a stronger oxidizing agent, so that I think you can handle it yourself. 咁啊呢邊冇特別㗎嚇，你 cat iron 嗰邊你其實諗晒 electrochemical series 已經搞掂㗎啦。So however, what happened on the right hand side?
I minus is oxidized.
Or I minus will undergo oxidation this time to form I2AQ. Maybe at this time I write down also the state symbol. Because last lesson, maybe in the last homework, some of you are confused about the state of I2 form. And because now I2 once it is formed, then it will dissolve back into the solution. So what you can see is some brown solution formed instead of some violet gas. So the state symbol for I2 should be AQ.
講係講即係 compare 個 concentration 啫，但係其實佢都冇俾個實際嘅 molarity。
係㗎，冇㗎，但係佢逢親大率嘅話咧，佢會出㗎啦。我就算係0.0幾 m 都好啦，你都理解成佢係大率㗎啦嘛，係嘛？咁但係就算0.0幾 m 都好，你比起咧個 OH minus 咧，佢1/10嘅負7次喎，係嘛？佢起碼係佢嘅一萬倍喎。咁喺呢一個咁嘅佢哋 electrochemical series 個距離之間咁短嘅時候，而佢 concentration 又係佢嘅1萬倍咧，佢就會出到嚟嘅。
即係已經係 default 咗佢係算係叫勁過佢嘅。
係啊，除非嗰個 I minus 個 concentration 係低到1/10嘅負7次啦，咁就會係嗰個 hydroxide ion 去 discharge 啦。咁但係當然啦，可能你如果係只係佢嘅10倍、10幾倍咁樣，你點先知道咧？咁冇辦法啦，你要真係要用 experiment 嚟 confirm 究竟邊隻嘢會 undergo reaction 先咯。喺嗰個 particular 嘅 setup 入邊。So in the explanation part, you have to emphasize two things. First thing is that under the same concentration, which one is a stronger reagent to react? And then now, because the concentration of I minus is much higher than that of hydroxide ion, so which of them now will really preferentially discharge? And if you do not know, just refer to the previous example, then you will know.跟唔跟到啊？成個 concept 係啲咩咧？呢個叫蟻多嬲死象嘅 concept。呢啲象明唔係好大力㗎嘛，係咪？咁正常佢贏啦，係咪？咁但係當啲蟻太多嘅時候，隻象都死啦。就即係 concentration 太高嘅時候，佢喺個 electrochemical series 入邊幾優勝都好，佢都冇用，就係咁。Oh, and then the next question, the observation at cathode and anode respectively. Cathode first.
Colorless bubbles.
Colorless gas bubble evolved because of hydrogen. Oh, then the anode.
anode 咩睇喎？睇黃色轉啡色咁啊？
應該係黃色嘅。
NAI 本身黃色噶嘛
？NAI 本身係黃色嘅咩
？loading。
我哋
希蘭唔係 colorless 嘅咩
？Yes, all halide ion are colorless, and then sodium ion are colorless. So originally it is a colorless solution.
Then from colorless to brown 咯。
Colorless to brown.
Because I was looking some photos of sodium iodide earlier.
But what if a NAI solution? You have to search photo for that.
OK。
嗱，不過咧上面嗰條 equation 就係 DSE level 嘅嘢啦嚇。實際上佢 I2 會再同 I minus 咧就合埋變咗 I3 minus 咧，先至係佢 deep brown in colour 嗰隻顏色嚟啦。咁變咗咯喎，你真係做實驗，你點知道係 I minus 乘一個 OH minus discharge 啫？好容易睇啫嘛，你睇住個 solution 有冇變啡色咪得咯。佢一變啡色嘅就即係 I minus 做嘢，冇變啡色嗰邊有 gas bubble 嘅咧就係 hydroxide ion 做嘢啦。你一做就知道邊隻嘢會 react 先嘅。Oh, and sometimes you will add some more reagent into the system to confirm the status of product form. And this time, what if starch is added?
Turn deep blue 啊。
Turn deep blue, why?
To indicate the presence of iodine solution.
To indicate the presence of iodine. And then if iodine combined with starch, it will form a deep blue complex ion. So final color this time will turn into deep blue in color instead of brown.咁呢個就係話，如果我喺個 system 入邊，你唔知道啊，究竟佢出嚟嗰隻嘢咧，即係你做 chemical test 最重要啦。佢如果咧原本入邊咧佢係 KBr 嘅話咧，其實佢都會令到個 solution 變做啡色嘅喎，係嘛？我點樣可以 confirm 喺嗰個嘅 set up 或者喺嗰個 test 入邊咧，究竟佢係有 bromide ion 啦，定抑或係 iodine ion 啦？就用 starch 呢一嚿嘢啦，係嘛？我將佢做 electrolysis 啦 ，and then if we form a brown solution。Then what if I add some starch solution in it? And if it originally is bromine, then no observable change here. It will remain brown in color. And if it is iodine ion at the beginning, then it will turn into blue-black.